Hey everyone, Happy New Year! Today I thought I would share with you the differences between the RYB color theory, the CMYK color theory, or as I like to call it when I'm painting, CMYKW color theory, and the RGB color theory. It is important that you know the differences between all three color theories and which one is best used for in certain cases. So before I get started into this video, I just want to let you guys know that I'm not here to tell you that a single color theory is correct or that one is wrong. I'm here to tell you what each three of these color theories are used for and how you can understand them in learning to paint, draw, or do digital artwork. So first, let's begin with the RYB color theory, which I bet many of you, this was your first color theory that you learned in elementary school. So the RYB color theory is a subtractive color theory which explains how pigments, such as inks or dyes, absorb, which is essentially subtracting certain wavelengths of white light and reflecting others with more pigment, resulting in darker colors, ultimately leading to black. Now, when I say ultimately leading to black, it doesn't make a perfect black, at least with the RYB color theory. I will show you with the CMYK color theory how it can make a more pure black, whereas the RYB color theory will make more of a brown color if you mix all three together. But the reason why you learn the RYB color theory usually before the CMYK color theory is because it's easiest to learn in a more elementary setting. Many of us find it easier to identify colors like red, yellow, and blue versus cyan and magenta at a younger age, which is why it's taught first in elementary schools. Also, the RYB color theory is much older and has been used for centuries by artists, making it an easy and comprehensible color theory to understand. Now, to really understand how colors mix together and the color theory behind them, you have to know a little bit of physics, like the wavelengths on how the differences between subtractive and additive colors work. And that's really important when you're doing painting or drawing versus a digital medium. Now, I didn't mean rocket science physics, I just meant like very basic light and color theories. So now I'll be showing you, using acrylic paints, how you can use red, yellow, and blue in the RYB color theory to make various different colors. And while I'm doing this, I'll be showing you how to make primary colors, which are colors that can't be mixed from any other colors, secondary colors, which can be mixed by mixing two primary colors, and tertiary colors, which can be made by mixing a primary color with its adjacent secondary color. So examples of the primary colors in this wheel include red, yellow, and blue. Examples of the secondary colors include purple/violet, green, and orange. And examples of the tertiary colors, just to name a few, would be like red-orange, blue-violet, yellow-orange, etc. So here are the red, yellow, and blue primary colors in this wheel, and I'll be mixing them to show you what colors you can get. So red, yellow, and blue. So I'm going to mix some red and yellow. And this will make orange, as you can see. And then I'm going to clean off my palette knife, some blue and red. And this will make kind of a purple, but you can see it's supposed to make a purple, but it's kind of more of a muddy color. It's not really like a vibrant purple. In fact, it's more like almost like a brown color. And then I'm going to mix yellow or blue. I just realized there's a little bit of contamination, so mix blue and yellow. So it's important to make sure your palette knife's clean. And by the way, I like using a palette knife more than a brush because I feel like you have more control. As you can see, I'm getting the colors that you would normally expect, but they're pretty dull. They're not as vibrant as you would think. And then if you mix all of these together, if we mix, let's try mix equal amounts of each. And let's see what we get. So And just because there's not much room right here, I'm kind of skipping over the tertiary colors, but to make the tertiary colors, you would just mix a primary with a secondary color. But as you can see right now, instead of black, I'm getting more of like almost like a brownish color, as you can see. So that's something to keep in mind. If you want to make browns, I recommend this is probably easier to just do red, yellow, and blue, and mixing all three of them in equal proportions will get you more of a brown color. So this is a RYB primary color wheel, and I think it's great, yeah, if you're learning as a beginner, but yeah, so you will get a lot more dulled down, a little less vibrant versions of your colors. As you can tell, I'm making brown instead of a black here. So now let's focus on the CMYK color theory, or as I like to call, the CMYKW color theory. So the CMYK color theory stands for cyan, magenta, yellow, and K, which represents black, and is used in printing. Now, I added W onto that which stands for white, because when I'm painting, I like to use white to lighten things up. Now, the CMYK color theory is much more modern and used in printers because you can make actually a wider range of more vibrant colors using CMYK. So why isn't CMYK taught to us first thing in elementary school as the color theory that we should use? Well, CMYK is much more modern than the RYB color theory, and primarily it's not taught to us because these colors are harder for younger people to remember, and red, yellow, and blue are often easily found in crayon sets, colored pencils, and many other beginner artist supplies. Also, many painters and artists across the world still use the RYB color theory because it's a standard color theory that has been used for centuries by artists and is also very comfortable among many teaching experts. So the primary colors in the CMYK color theory are cyan, magenta, and yellow. And black's on there because it's often just an easy prefix for the printer to use. However, black can be made in theory by mixing equal proportions of cyan, yellow, and magenta. And the secondary colors are blue, red, and green, which you'll notice when I talk about the RGB color theory, those are actually the primary colors in additive color theory. So there is a little bit of a reverse here. And then the tertiary colors are made by mixing a primary color with its adjacent secondary color. So just like the RYB color theory, however, they're slightly different in the CMYK color theory. So you may be wondering, why do we make black or a very dark color in the CMYK color theory, just like we make a very dark brown in the RYB color theory? The reason why we make a really dark color, like black, is because it absorbs all wavelengths of visible light. Well, technically not all wavelengths, because if it absorbed all wavelengths of visible light, then we wouldn't be able to see it with our naked eye. But in theory, black absorbs all wavelengths, or at least true black absorbs all wavelengths of visible light, which is why mixing equal proportions of cyan, yellow, and magenta should make a black. So let me show you how the CMYK color theory can be applied to acrylic paints. And I'll also be adding white into this color theory because I use white to lighten up different colors in my paintings. Now I want you guys to know that white in a subtractive color theory cannot be mixed. It's something that must be found from an existing pigment. Unlike in the additive color theory, white can be mixed by combining all wavelengths of color. Oftentimes in colored printing, they avoid using a white key because the paper is already white. So they just use cyan, magenta, yellow, and black. So here is the CMY color theory, or color wheel in acrylics. And with the CMY primary wheel, I'm also using acrylics just like I did with the RYB primary wheel. So my colors are magenta, cyan, and yellow. And I'll be mixing these across the wheel to show you what colors I can make. So first of all, I'm going to start with equal proportions of magenta and yellow. And right now I'm making, this looks orange, but it's actually, I can actually mix red by mixing yellow and magenta. And you can see how this is a much more vibrant color than the RYB primary wheel. And in this wheel, red is a secondary color, not a primary color. So I made a very rich red, almost a little bit kind of orangey, and then let's mix, but it's very vibrant. Let's mix equal proportions of magenta and cyan. What color do you think I'll get? Let's see. But look at that. That looks like a deep blue, right? A very vibrant blue. And then, so I mixed blue out of cyan and magenta. And then the last color we'll be making, or the last secondary color we'll be making is green. So this green, I'm taking equal proportions of yellow. I just realized this yellow is a little contaminated, so I'm going to fix that. I'm taking out of the non-contaminated side because we don't want any red in this. I'm just taking some yellow and then some cyan. And then I'm going to mix this together right here. Probably use a little bit more. I think I might have put a little too much cyan in. Just add a little bit more yellow. You can already tell right away that this green is much more vibrant than the green with the RYB wheel. So now I have my 3 secondary colors. So I have red, blue, and green, which these colors are actually the primary colors of the additive color theory wheel. Now if we mix equal proportions of magenta, yellow, and cyan, we should get black. So I'm going to use some magenta, cyan, and yellow. It's kind of too green. Mixing it right now it looks a little bit like a dark brown, so we should add some more cyan to it. And you can already tell right away that this looks much more like a true black. I mean, it's a really dark gray because if it was true black, we wouldn't be able to see it. But it looks much more like a true black than the brownish color that I made using the RYB primary wheel. So that's why I think this color wheel is superior in terms of accuracy and color, accuracy and what is more scientifically accurate. So yeah, these are the 2 primary wheels that use subtractive color theory. Another important thing to note is complementary colors. Complementary colors are colors on the opposite side of the color wheel. An example for the RYB primary wheel would be orange and blue. Combining orange and blue should make this brown color in the middle. For the CMY primary wheel, an example of a complementary color would be red and cyan, and combining them would make this blackish dark gray color in the middle. So there you have it. The RYB primary color wheel is best for those who are just starting out and want to make browns easily out of red, yellow, and blue. However, the CMY primary wheel is superior when making vibrant colors and a more neutral and rich black. So the third and final color theory that I think is really important for artists to know is the RGB color theory, especially for artists who plan on doing digital work. So the RGB color theory is an additive color theory that explains how colors are created by adding different wavelengths of light, like red, green, and blue, and this is a very basic principle in physics. Also, if you look at a rainbow in the sky, it uses an additive color theory using red, green, and blue, which adds all the different wavelengths to make white, or white light. So who is the RGB color theory best for? Well, the RGB color theory is best for digital designers, graphic designers, or any digital artist that uses a computer to create artwork. The RGB color theory also explains how you get various colors on a screen. For example, when you're watching television or anything on a computer screen or smartphone or tablet, you see a variation of red, green, and blue pixels mixing together to make a variety of different colors. It's also how you see different colors on your YouTube video right now on the screen. Now, if you look very closely on a screen that has wide pixels or big pixels, you'll often see variations of red, green, and blue, because these are the foundational colors that make up each tiny color in a pixel on a computer. So you may be wondering, where does black fit in the additive color theory of RGB? Well, black is the absence of all colors in the additive color theory, but to put it more precisely in physical terms, it's the absence of all visible wavelengths that our eyes can see in the RGB additive color theory. So true black, which we technically wouldn't be able to see, would reflect no visible wavelengths back to our eyes. And this is why you can't mix black light using the primary colors of red, green, and blue in additive color theory, because black is the absence of all colors in additive color theory. So you may notice a pattern. In the subtractive color theories that I taught you guys, RYB and CMYK, or as I like to call it, CMYKW, white cannot be mixed, meaning that it's the absence of all colors in the subtractive theory. Now, in the additive theory, RGB, red, green, and blue, white can be mixed by combining all the visible wavelengths together, and black cannot be mixed. So in the subtractive theory, black can be mixed, or a color very close to black can be mixed. So it's important that you notice these patterns when you're choosing a color theory to create your artwork off of. So knowing these three color wheels as an artist is truly a must if you really want to create realistic artwork. Now, color theory is not enough for creating artwork alone. You still must master proportions, form, value, and texture to create realistic artwork. In fact, you can create many realistic pieces without color theory in black and white if you truly understand proportions, value, texture, and form. But color theory is crucial if you want to use various hues in your drawings, paintings, digital artworks, or whatever mediums you use. Also, another important thing to add on to that is color theory is also important for saturation, which is basically how vibrant or dull your color is. So a more vibrant color will be more saturated, and a more dull color will be less saturated. Now, I hope you found it helpful for me to compare these three color theories that I believe all artists should know, and please do subscribe to my channel as it really helps me deliver videos to you, and it is completely free to subscribe. Now have a great rest of your day, and go get drawing, painting, or creating artwork. Bye everybody.